Hello, everyone. Welcome back to our series on Office 365 and eDiscovery. Today is going to be what is really Chapter 7, Session 7, I guess you could say. We've, over the past two sessions, done a really deep look at searching in Office 365, and today we're going to talk about what flows next out of that, which is some sort of analytics or review of your search results. This, of course, is Tom O'Connor from the Gulf Coast Legal Technology Center in New Orleans. And as always, I'm joined by Rocky Messing, the Senior Program Manager at Microsoft Legal. Rocky, how are you today?
Today I'm doing great. It's a beautiful day today.
Excellent, excellent. Well, good. And I'm, as always, going to let you carry the ball here. I'm really interested in seeing, as I mentioned, we spent some time talking about searches and how to do searching and some of the different strategies you can employ there. But now, what do we do with it once we found or have these search results? How are we going to play with all this good stuff that we found? So why don't you tell us about that?
Okay, so what I'm going to do is I'm going to walk through some of the analytics that are available from just pure what are they, what do they do, and then at the end of this session we'll talk a little bit of kind of why we're doing it and some of the advantages and the benefits that we see by using the various different analytics tools that we'll have walked through. So we are going to go back into our review set that we were already dealing with in the last time and looking at how we were filtering things. And you can see that, again, we've got about 20,000 plus items here in this review set. And what we're going to do is we're going to go to the Manage Review Set section, and you can see here that there's a section for running the analytics. So I've actually already run this, and I'll show you here that when we ran the analytics, it created a job, just like everything else, and that job ran a number of different analytics tools against the data. So we have our near duplicates, our email threads, themes, as well as some other back-end analytics. For example, I talked a little bit in the last session about building classifiers automatically to detect priv documents and do other types of things. Those types of analytics also would be run against the review set data when I kick off the job of running analytics against the data. Now, once that job is done, then if we come back in here, we can see that we have a report that gives us just a little bit of a breakdown of the data that we're dealing with. And we can see that we've got it broken down in a number of different ways. And again, analytics is about how do I understand what I have, what can I be told about the data without having to actually look at it and without actually having to understand what the content is. What can the machine help me to understand about the data itself? And there's all kinds of different ways to go about doing that. We use a number of different algorithms here in order to determine some of these different aspects of the data. So for example, when we look at our emails, we're able to see that it's broken out by different categories of inclusive emails, inclusive copy emails, the inclusive minus emails, as well as the rest. And what this is telling us is, Tom, let's say you and I are having an email conversation about setting up today's training. And I send you an email saying, hey, Tom, what time's good for you? And you reply back to me and you say, whatever you say, right? you say, how about 7 o'clock?
Yeah.
You say, man, that's way too early. We don't want to do that. You say, okay, how about 10:30? I said, okay, that's a little bit better. So that was just 5 different emails going back and forth between us.
Right.
Now, let's say for whatever reason, those emails show up in my eDiscovery search. And as an attorney, if I need to look at those and I have to look at each of the 5, well, if I just look at them based off of the time sent and date order, then I might see first the email from you, and then I might see 8 other emails from someone else, right? I might see then maybe our emails were actually on different days, and I might have 20, 30, 500 emails in between them, right? So the first thing that we're doing is we're grouping the conversations together in order to make sure that it's as efficient and consistent for the reviewer to look at that data. The second thing, though, that we're doing is we're determining, does all of the data in each of those different emails actually have to be looked at? Because in most email conversations, that last email where I said, okay, that sounds a lot better, let's do 10:30, that one actually contains all of the prior emails. So what we do is we look and we say, does it actually in reality contain all those emails? And if it does, mark that one as being the inclusive email, so meaning it includes all the other ones, and the rest of them, mark them as being the rest, where I don't actually have to even bother to read those. And if I've got, for example, let's say both you and I were both custodians, so we collected the emails from both of us, well, we're going to have copies of those because I have the version that I sent of each of those. You have the version that you received, and then you have the version that you sent, and I have that version, the same exact thing, in what I received. So part of this is identifying which emails are the same, which have the same content, and then finally, which ones actually have to be read. And we'll take a look at some examples of that. We're also looking at, from a textual standpoint, on a near dupe and an exact dupe perspective. So finding documents which are the exact duplicates, meaning if I run a hashing algorithm against those, and I actually figure out, is the content of them exactly 100% the same? Right. Then sure, I'll be able to identify 2 Word documents that are the exact same. But what if I take one of those Word documents and I convert it to a PDF?
Yep.
From a hashing perspective, you know very well that those will not come up with the same hash, right?
Yes.
However, the content of those are actually exactly the same. So we're going to identify those as 100% similar, even though they're not exact dupes, but they're 100% similar. And then let's say I've got a draft version of the Word document before I finalized it and made it into a PDF. That draft document might be very, very similar to the final Word document in the PDF, but it's not exactly the same. So we're going to identify documents that are similar to them based off of a threshold that you're able to set in your...
And Rocky, could I throw a curveball here for you?
Sure.
Well, you talked in our last session about importing non-Office 365 documents. What if I have a version of that email that was sent via Gmail, and I was able to import that external email in? That, as I understand it, would also change the hash values, even if it was the same email.
Correct. So those would not come out as being exact duplicates. Right. They would, however, be identified based off of the analysis of the header information, the subject, and all of the text in the content, in the body of the email. They will be identified as being as part of the same thread, and therefore they will get threaded together, as well as they potentially may show up as being either 100% duplicate in terms of similarity, or potentially they'll just be 95% similar or something like that, based off of any differences in the structure or anything else that might have changed between Gmail and Outlook.
And does the header content count there?
So the header content will count in terms of evaluating it for the thread. Yeah. It'll count as text in the document in terms of identifying it, whether or not it's similar, if that text is contained within the document itself, right, in the text version of the document. Yeah. If it's just pure header metadata that's not actually extracted in the extracted text, then it will not count towards the near duping. similarity.
Gotcha. Okay, great. Sorry to divert you there.
No, absolutely. Okay, so we've got all kinds of different ways of looking at the data. One of the things that the system does when it goes ahead and runs the analytics, it will automatically generate this query called for review. And what the for review query is going to do is it will look specifically for different types of unique documents in the document set. So within this review set, we have got, again, 20,000 total items, but when I hit the for review query, and it looks to say, only show me the inclusive emails, meaning the ones that have unique content in them, only show me the documents that are actually unique. You can see it restricts this data set down to under 2,000 items, right? So we can basically say that by looking at just 10% of the total population here, and this is in truth, this is a demo set, it's a pretty drastic example, but we typically will see a 40 to 50% reduction in the data just by using these types of algorithms to break it down. Now, what does this data look like when we actually start looking at it? Let's take a look at an email here. And again, we've got our tagging panel that we had set up before. You can see I've got an email, and I've got now some various different icons here on the right-hand side, and I'm going to hit the conversation icon, which shows that there's actually 24 emails in this conversation. Now, a lot of them are duplicates of each other, but some of them are considered to be inclusive, right? Meaning that they are the final email in the chain, that they contain unique content that the other emails don't necessarily contain. And some of them, right, you can see here that it's got different content from the one before it.
Yep.
And some of them are considered none, meaning that they are the ones that are actually don't have to be reviewed. So you can see here, I've got this email. It's got content that's contained similar in each of them, right?
Yep.
But the top one, or the right one here, has content that makes it inclusive, meaning it is more inclusive than the other one, and that's the one that actually needs to be reviewed because it has unique content. So that is part of what the email threading algorithm is doing, along with the near dupe comparison view that we can see. We can also see, let's go ahead and look at, let me quickly pull up, give me 1 second here.
When it's time to head out, sometimes
See, that's why this video series is informal.
Because I get announcements on my thing. It's hard. This is a real a problem in our world. Of course, I'm live on the internet, so I have to have my volume turned up so people can hear me pontificate. But then when I get some unwarranted announcement from somebody about a great new deal on sneakers that I can't afford to miss, it pops up on me and starts blasting.
Okay, so let's take a look. This is a Word document that we're going to take a look at. And what I can see is that it has a number of near duplicates. And if I go into them, I can see that the first one, right, is missing 3 lines that exist in the second one. Are they duplicates? No. But this way, from an efficiency standpoint, I can look at all of these at once. I can come in here and I can say, okay, I've looked at each one of these 5 documents, the main document and its 4 near duplicates. I determined that none of them are actually relevant. And I can come in here and I can say, do I want to review those later? No. And tag them all at once. So again, it's all about how do I make this as efficient as possible in terms of the organizing and analyzing of the data. Now, let's take a look at one other type of analytics that we ran here, and that is the analytics of themes. So we are going to look at our dominant themes here. And what themes does is it'll actually go ahead and it'll look at this is a different type of analytics, because this is a content analytics that's looking to understand what's going on within the data, pulling out keywords, pulling out key concepts within the data. And I can see my entire list of the concepts that it pulled out. And I can then, for example, say, actually, this Windows file system use is actually exactly what I'm interested in here. So I can use it to help narrow down and understand different types of data that is actually being pulled out within this data set. So I can then go in and find things that have to do with file system usage and computer usage and things like that. It's not necessarily going to have the exact words that I'm looking for, or that the concept or the theme said it is, but it's things that have to generally do with that idea. It helps me to hone in on important information, or potentially find information that I don't care about and I can eliminate from my review. That's a little bit harder because of the overlap of themes, right? Just because a document is talking about birthday parties doesn't mean that it's also not talking about, well, when we get together at the birthday party, let's go ahead and commit fraud. Right?
Right. Or an example I've used going way back to just simple word searching in the old days, something could be talking about diamonds, and that could mean jewelry, or it could mean baseball.
Exactly.
So how are these themes generated, Rocky?
So the way that the algorithm works is it basically will look at the data that you have. It'll look at all the content, and it'll look at how the words relate to one another. And then it'll look at how those words that relate to one another relate to sets of documents. It's an algorithm that's actually called LDA. I just gave a very, very simple, simplistic summary of how that algorithm works. But it's really, what it's doing is it's looking to identify the first groups of words, look at what how they're similar, look at how they're used together, and then looking at what types of documents are using those types of words, and then grouping the concepts together. So it's a pretty complex algorithm, actually, in terms of
Sure.
really tried to dig in. But the bottom line is that it gives you a good overall sense of what the documents have to do with. So let's actually talk a little bit about how I can use some of these different analytics.
Well, let me interject one more question again to put you on the spot. Sure. So you've got this algorithm for themes. I presume there's the other things we looked at, near duping. Those are all individual algorithms. Would that be accurate?
Yes, each one of those is using a separate, different algorithm, sometimes a different algorithm, different machine learning based model to create whatever that tool is supposed to do.
Words that are near and dear to my heart, as you know, machine learning. But my question really was, so when I run analytics, are all of those running simultaneously? Can I just choose to run themes or run near dupes? How does that work physically?
So from a technical perspective, the way that it's working here is when I run analytics, it runs them all. And it will run them in parallel, the ones that it's able to be able to speed it up as quickly as it can. In your case settings, you do have some various different settings in terms of, for example, do I want to run themes? What are the maximum number of themes that I actually want to pull out of my view set? Do I include numbers in themes, right? Because sometimes numbers is just going to be noise. I have my similarity. How similar do documents need to be in order for them to be considered near duplicates? So I've got all kinds of different settings here that I can use to help determine how it's going to run. But they are, from a technical perspective, they're all run at the same time.
Great. Okay. Thanks.
Yep. So, and you know what? You reminded me. Let's go through one more quick thing, which is In addition to those analytics, we do have one last level of analytics that we can run, and that is relevance. And relevance is the ability to run predictive coding on the data in place. So I've got the data that is in this review set, and I can actually run a predictive coding exercise. Some people will call it TAR, some people will call it predictive coding. But basically what it's doing is it's used to actually go ahead and create an issue, right? What am I trying to train the system on? And then it'll walk through the process of reviewing some documents using an active learning algorithm to be able to help determine which documents are more likely or less likely to have to do with that issue. And I can use this either for culling, meaning I've got 20,000 documents, or let's say I've got 1 million documents, and I want to try to only review the ones that are most likely to be relevant. And that is where we would get into some of our statistics around recall and precision, all things that are really, really important, and we can discuss those at length at a later time. But the idea is to use it to either cull down my data set, or at least to prioritize my data set. Use the machine learning algorithm in order to help me to determine which documents should be reviewed first, because they're the most likely to actually contain relevant data.
Right.
So all kinds of different things that I can do there. And the bottom line with all of this is, we internally at Microsoft, we utilize these different technologies to help us in a lot of different ways. One of the main ways is that we do use it to help us cull down the data set. Just simply using the email threading and the near duplicate algorithms can help us at times to, like I said, reduce the data set by 40%, reduce our costs there in terms of the data that has to be looked at and reviewed and hosted. We're also able to utilize the themes to help us understand the data better, as well as using the predictive coding. We'll use it to identify hot documents. We'll use it to cut down on the data set. We'll use it to prioritize. So there's all different ways to utilize these various different analytics built in to the system that you're getting when you're utilizing the Office 365 eDiscovery tools. And all of them help you to, again, be as efficient and as organized in my document review process as possible. So that will wrap us up, Tom, unless you've got any more curveballs to throw at me for today.
Well, as long as you're asking me to bring one. So I asked just a moment ago about running the analytics. What's the overhead on your machine? And I know some of that depends on your network and the type of machine you're running on, but what sort of in the size of your collection here?
Yeah.
You know, how long can we estimate that it would take to run something like this? I mean, should people plan on running it overnight, lunchtime, come in an hour early in the morning? What's your recommendation there?
So what you can see here is that the analytics ran, I've actually run them twice on this set. It's 20,000 documents. It ran for about 20 minutes the first time, ran for about a half hour the second time. It's running in the cloud. So it doesn't matter your machine's specifications. It's all running up in the Microsoft data centers in the cloud. Now, some of the time has to do with overhead of just kicking off the processes, which is why you'll see variations. You'll also see if I would have had 50,000 documents here, the time wouldn't be that much different. If I had 1 million documents, yeah, it would take a lot longer.
Gotcha.
The set of data won't take drastically longer depending on what it is. The team, as we said when we started the whole series, these tools are just being released now in terms of this new advanced eDiscovery 2.0 set of tools. A lot of these tools have been in existence in the 1.0 world for a while, in the older Office 365 eDiscovery tool set. So as they're moving them here, they're slowly beginning the process of optimizing them even more. So I would only expect and hope that they would get even faster, but you do need to allow some time for them to actually run. That definitely has to be worked into your timelines there.
Right. So I think you just took my curveball and wrapped a solid double up the 5.5 hole, as Tony Gwynn used to talk about that little space between third base and shortstop. I think that's all. Well, actually, I have one. You made me think of something that I'd like to ask, which is at Legal Tech this year, I went to a presentation by our friend and Microsoft partner, Don Swanson, at the Microsoft Center that was down off Times Square. And when I walked into that building or into that facility, there was a large ante room filled with lots of computers. It looked like a server room. Was that part of the cloud? Is that part of it, your cloud structure? Or is that just a bunch of...
So that is not actually part of the cloud. That was a demo to show what some of the cloud systems look like. I think okay. you were looking at that. It probably had about 10 server racks in there, give or take, something like that.
Yeah.
And our cloud data centers are probably, I mean, they're running. Some of them are running 1 million plus servers in them.
Okay, so a little bit bigger space than what I was looking at.
Exactly, and that's really why, like we talked about in our intro to Office 365 overall. I mean, that has to do with the scale and what is happening in terms of the computing power in the cloud allows us to do so many of these different things that would have taken a lot of machines locally, but once we're able to scale it out and utilize that compute power that's up there in the cloud, it really opens up a lot more capabilities that we didn't have before.
Right, understood. All right, well, Rocky, I know you have some other pressing engagements today, and I appreciate your time on this and answering some of my additional questions. We'll wrap it up and look forward to seeing everybody in our next session in another week or so. Thanks, Rocky.
Awesome. Thanks, Tom.